Hello. Today in this video, we're going to talk about chain of thought prompting and how it is used to elicit reasoning in large language models. So let us start talking about language models. The growth of language models today has been very drastic and very groundbreaking, especially when it comes to large language models. Large language models are language models that basically use a large number of parameters or coefficients in the scale of billions, hundreds of billions almost. And these large language models are used across a very wide range of natural language tasks, such as text summarization, autocompletion, topic modeling, sentiment analysis, etc. And these range from a variety of like small level tasks to very complicated tasks. And all of these tasks see benefits in their performance when we see there's a scaling in the language models. For example, which means that when you increase the scale of the model from some millions of parameters to billions, these tasks have better performance with these bigger, larger language models. And not just performance, there is improvement in generalization and also efficiency. And so we see that scaling is not just necessary for these tasks, it's just necessary and sufficient for these tasks. But when it comes to certain tasks, such as arithmetic reasoning, common sense reasoning, and symbolic reasoning, we see that scaling is, while it is necessary to have a large language model, it is not always sufficient. There is something else we need in order to increase the performance of these models, apart from just the scale of the model. And so that brings us to chain of thought prompting. What is chain of thought prompting? Chain of thought prompting is a series of steps that are followed by the human human mind when it's trying to solve a complicated problem, reasoning or otherwise. So, for example, uh, every human being or mostly our children are taught that these kind of steps when they are initially taught reasoning or arithmetic. Say for example, you say X has three apples, and X is now additionally given a box of two boxes of three apples each. How many apples does X now have? And so the human thought follows the process that initially X had three number of apples. Now there is two boxes of three apples each, which is 2 into 3, 6 apples. So initial 3 apples plus now 6 apples gives rise to 9 apples. So X now has 9 apples. So these are the series of steps, and it differs on the efficiency and type of the model and the how fast the human has can calculate, etc. But these are the basic steps that are followed in chain of thought reasoning in human beings. And this is what is trying to be emulated in chain of thought prompting for these models, for these arithmetic reasoning tasks. So in chain of thought prompting, we try to combine two approaches. One is that large language models can be trained to generate intermediate natural language steps. So giving these intermediate rationales to the model is of very much added benefit. And secondly, having been these models already have been successful at question answering tasks with just few short prompts. So few short prompting means giving a number of prompts as examples in the prompt itself, and these models perform really well. So we combine these two approaches to give these models few short chain of thought prompts. So, what are the benefits, general benefits of chain of thought prompting? One is that because we divide these problems into steps, intermediate steps, these models can provide additional computation to when there are very complicated problems. Additional computation can be provided to intermediate steps as necessary. Secondly, where these because again there is a series of steps that are followed, we can in a broad general way find out where in reasoning the model went wrong, and it kind of helps us in sort of debugging the model, not the actual inner workings of the model, but what the answers that it gives. And thirdly, we can turn a very generalized LLM into one that can perform very complicated reasoning tasks and other complicated tasks. So let us first start with arithmetic reasoning and how it performs. So since this is a survey paper, we have certain surveys that are performed with benchmark math word problem sets that we have here on the rows. And the columns are for three models. We have the Lambda, GPT, and the PLM behind this audio thing. So here we see, and on the x-axis of each of these graphs, we have the scale of the models, which is the number of parameters, and we see it's increasing as we move right. Let us talk about some of the conclusions that can be derived from this. So as we see here, the performance of with standard prompting of these models, which is in black, and the chain of thought prompting, which is in um, uh, blue, is very drastic when it comes to larger language models. So while even with standard prompting, we see the performance increasing as the model scale increases. With chain of thought promptings, that performance is very drastically increased. So we see that it is necessary. So we see that this is proof that scale is not is necessary, but not just sufficient. We need chain of thought prompting for the improved performance. Secondly, we see that given the fact that GSM 8K, the sample of questions that are in this are much more complex than the sample of questions in the MAWPS, we see that chain of thought prompting performs much better when it comes to these more complicated set of problems than the less complicated ones, which shows us some kind of correlation between performance and the problem complexity. And thirdly, we see that the chain of thought prompting beats a previous state of the art, which is the orange dash line. And the previous state of the art was just a supervised trained label data set that was given and supervised learning. And so it beats even that with just a few examples. So we see that the performance is much better than before. Next, let us talk about some ablation studies, some variations, and some intuitions that chain of thought prompting may not be as important, but we see how it is definitely needed and required. In the first variation of the chain of thought prompting, we ask the model we prompt the model only to give an equation to a math word problem and not just the actual solution, just the equation. And we see that it does not perform well. It does not perform well, and this is because the semantic understanding that is needed to understand these math word problems is not easy for the model without giving the intermediate steps that are there in chain of thought prompting. So we see that in the first case, and in the second case, variable compute only. The intuition is that these chain of thought prompting models with chain of thought prompting perform much better because of the additional computation that can be given to more complicated problems. And when we test this, we see that again these models with variable do not perform so much better than the baseline models, which lead us to believe that this chain of thought prompting not only provides variable computation, but there is something more that it provides apart from that, which is needed. And third variation of that was in the third variation, the intuition is that the chain of thought prompting gives it some kind of added knowledge to the model, which then allows it to perform so well, almost like pre-training the model. And so in this variation, we give the chain of thought after the answer in the prompts. And again, we see the model does not perform as much better than the baseline model, which leads us to believe that chain of thought prompts not only provide additional knowledge, unlock certain knowledge in the model, but also the the steps that are sequential steps give so much more to the model that it performs so much better when given the chain of thought prompts. And this we can see in the graph too, how it performs, chain of thought prompting performs much better than these various uh, studies that we have. Next, we talk about the robustness of chain of thought prompting, which is basically trying different styles of chain of thought prompting to see if it still performs better in all of these cases. So if you see these, the red patterned variations, we see that in these cases, the annotators who are giving the annotations, the prompts or the annotations are different, and so obviously the prompts will vary from one to other with different annotators. And in here, the third one is the chain of thought prompt is given in a very concise manner, but we see that each of them still performs much better than, even though the performance is variant, we still see that it performs much better than the normal standard prompting. And in the yellow, the brown things are where the prompts are exemplars from the GSM 8K math problem set. We see that different kinds of exemplars are given alpha, beta, and gamma different sets. But we still see that while there's variation in their performance, they still perform much better than just normal standard prompting. And so this leads us to believe that the linguistic differences between chain of thought prompting is not very important. What matters the most is giving a good chain of thought reasoning in the prompts, which leads us to believe that it's robust against the linguistic differences in chain of thought prompting. So let's talk about some other reasoning tasks. Like on the left, we have the common sense reasoning performance of the PALM model, and on the right, we have symbolic reasoning performance of the PALM model. So on the left, we see that this PALM model chain of thought prompting does not perform so much better than standard prompting in CSQA set. But if you see strategy QA, we see that it beats the previous supervised state of the art. And in sports, it also beats even the human sports enthusiast at sports understanding and knowledge, which leads us to believe that even though chain of thought prompting is meant mostly or is even is the best performing, is effective for arithmetic reasoning, it also performs very well even for other reasoning tasks like common sense reasoning. And we have symbolic reasoning on the right here. And symbolic reasoning is very hard for natural language models because they're not meant to be symbolically reasoning, because those symbols are symbols of human knowledge and human understanding. But we see here that there are two tasks that are there. Each row is a task, and the first task is concatenating the last letters of a name together. And the second task is coin flipping, where the model is given the initial state of the coin, heads up or down, and then it's given a series of tosses. Say X tossed it once, Y tossed it once. What is the state of the coin now? Tossed it like flipped it once. So what is the state of the coin now? So we see that there is in-domain and out-of-domain testing. In-domain testing, we see that the test is performed on two steps, and exemplars that are given are also two steps. So it's almost like a toy task in domain tasks, but we still see that at least in the first case, the standard prompting does not perform well at all, and chain of thought prompting it performs extremely well. Similarly, in the second one, while we see the standard prompting performs pretty okay, we see that chain of thought prompting is better. And in the second column, which is out of domain, which means that the exemplars that are given in prompts are based like two step exemplars, and the prompt is actually the test is actually for 4 steps. So it is a leap for the model, but it still performs chain of thought prompting still performs so much better than standard prompting, who's either has a reduced performance or like a standard normal performance, zero performance, which leads us to believe that chain of thought prompting is much better even for these tasks, which are very hard for a natural language model to perform. Finally, let us come to the limitations and the conclusions of this. So some of the limitations or rather questions that we ask are, since these models, a chain of thought prompting is kind of emulating the way a human being thinks, is the model really reasoning on its own, or is it just simply imitating or emulating the human thought process? There's no direct answer for this, and more research has to be performed. This is one of the questions that has to be asked. Secondly, already to give annotations to for a few chain of thought prompting is quite it takes some amount of time and money. It's costly, but um, performing fine tuning on such models, such large language models, will increase the cost of annotation very drastically. Third, there is no guarantee that this model will take the right reasoning path that you provide in the chain of thought prompting. While you can say this is the way that it should be done, the problem should be solved, you cannot guarantee that the model will actually take that reasoning path the right reasoning path, which is given by you, the annotator. And the fourth limitation or question that we ask is what is the cost of employing such large language models for real world applications? Although there are many examples of being large language models being used, it's very hard to use in normal applications without having a large, resources. So there is a large cost to this. So in conclusion, we see that chain of thought prompting is really necessary apart from the model scale in order for us to elicit reasoning, arithmetic, symbolic, or common sense reasoning in these large language models. So what we need to do as we go further in this, there are two parts we need to focus on. One is broadening the range of tasks that we perform. So right now it's just for like three types of reasoning, but there are so many other tasks that they can be trained on to see if they perform better with chain of thought prompting. And if this can be better because it's much better than training with a labeled data set. And secondly, decreasing the scale threshold at which reasoning is seen in these large language models with chain of thought prompting, because as we know, the cost of these models, large language models, can be really high when the scale of these go up. So can we reduce the scale and see the same better results in the smaller scale models? So this paper is can we the reference to this paper is given here, and can we always you can always read it and see about it. And thank you for watching this.